quick introduction. We only have an hour, and there's all kinds of stuff that I would like to share, so I won't bore you with too many details outside of our topic. The title here is Entity Framework, Database Performance, Anti-Patterns, but it was a really long title, so I just reduced it to Anti-Patterns. And why Anti-Patterns? Well, it's because I am not a coder by trade. I am a DBA, a database administrator by trade. So when it comes to Entity Framework, I'm way better at showing you how not to do it than how to do it. I will leave that to you as a professional coder, but I'm going to show you a handful of things that I run into as a database administrator that has caused me to work with some of my fellow coders and dig into Entity Framework and see how Entity Framework talks to SQL Server and frankly even other database platforms, but how it does that so that we can get it running in high performance. Because even though I'm not a professional coder, I am a hobby coder and I am a coding enthusiast. I do like writing code, and frankly I'm kind of a fan of Entity Framework. It does have some really intriguing and interesting things and makes that coding process easier. Because even as a database administrator, I don't like writing CRUD, which is an acronym for Create, Read, Update, and Delete. And ORMs make that really nice. So my name is Russ Thomas. Here's my Twitter handle and my blog. Though ever since I became a Pluralsight author, I don't blog as much as I would like or as I used to. And as far as the title goes, my boss at my current full-time gig said that I could pick my own title as long as it didn't affect my paycheck. And so that is the title that I chose. All right, so let's get on with this. What we're going to cover real quick is I'm just going to give you some kind of internal, I'm going to give you an internal peek into how SQL Server manages memory and manages data. And it all has to do with relational theory that goes all the way back to high school algebra. In order for SQL Server to work at its best, it has to go through a process known as query optimization. And so we'll cover that just real briefly and how it interacts with both relational theory and the SQL Server memory space. And then on top of all that, how Entity Framework kind of sits on top of that and the effect that that has. So SQL Server stores data on disk. Ultimately, that is where it's stored on disk because data that is stored on disk is durable. It doesn't suffer a complete wipeout when you have a loss of power. So ultimately, it has to go to disk. Now, we could store all of our data in just one big giant end-to-end text file. So imagine, if you will, 14 or 15 terabytes of data stored in a text file. And then search that for, let's say, a last name. Modern computers could do that. And frankly, there's even other applications out there that can get really fancy about searching that kind of flat file data. That's when you get into concepts and topics of things like MapReduce. But for data to really have meaning, it has to have relation, and so SQL Server as a relational engine stores its data in a way that it can use relational theory to best access that data quickly. So the fundamental storage unit of a SQL Server database is that 8 kilobyte page. And it's just an 8 kilobyte block of data out on your storage. And everything that SQL Server stores gets chunked up into these little 8 kilobyte blocks. And those 8 kilobyte blocks are organized into bigger blocks known as extents, and they themselves have an 8 kilobyte page that kind of manages which pages are in that extent. And ultimately, it's all stored in kind of a B-tree format. Well, if it's indexed and has a clustering index, but we won't get too deep into that. It can be also a heap, but ultimately, what we're concerned about is these 8 kilobyte pages. But for SQL Server to efficiently acquire the data that you're looking for, it ultimately has to pull all of those pages into the memory space. Everything that SQL Server does is in memory. Anything outside of memory that SQL Server does is kind of delegated out to the underlying storage system or the underlying operating system. Which is why when you install SQL Server on any kind of box, and those of you that have done this, you immediately notice, and sysadmins love this, that SQL Server will take every last bit of available memory and pull it into its own. Because SQL Server has an internal engine, and the engine is called the SQL OS, SQL operating system, that manages that memory and takes a lot of that away from the operating system. So the thing to remember is that for relational theory, so unions, joins, exceptions, and all the concepts of normalization and set-based theory, for that to really work well, we need two things for it to be high performance. We need an efficient set-based way to get that data off of disk and then load it into memory. Because once that data is in memory, we're still going to work with it in a relational way, but it is exponentially faster. All right, that is the baseline. So the language of SQL Server and other SQL other SQL databases such as Oracle or MySQL or Postgres is SQL. Now with SQL Server, which is going to be our focus, it's a subset or a flavor of the SQL standard language known as T-SQL. So when you issue a T-SQL query, like select name from table where last name equals Thomas, that doesn't just get handed immediately out to the disk subsystem where it can go and find all those records. It first goes through an optimization process. That optimization process is it's a very complex compiler that goes through relational algebra. It goes through a lot of statistics and real heady math to figure out what is the best way to acquire this data. And ultimately, it will take into consideration if those data pages are already in memory. That saves it a lot of work. But this is a pretty complex process, and it is heavily, heavily affected by the T-SQL syntax. You could pass two very different queries that have identical results, and even though the result set is identical, based on the two different styles of query, the optimization process might come up with two wildly different plans for getting those data pages off of disk into memory and back to you as the consumer. So it's really important that your T-SQL is very efficient and well organized, well tuned, and well formatted. When you put an abstraction layer on top of that, such as Entity Framework or really any other ORM, it definitely adds complexity to that generation of T-SQL. Something that is a surprise to some developers is that Entity Framework isn't talking directly to the SQL Server engine. Everything the Entity Framework passes to a SQL Server has to first be converted into T-SQL so that it can go through this optimization process and ultimately retrieve the physical data. So the question that we have before us is, how do we get Entity Framework to pass the best T-SQL possible to give the optimization process the best chance possible of giving us a high performance result set? And that is the focus of this course. There are a lot of applications out there whose data sets are small enough that maybe the entire data set can fit in memory and performance isn't a concern. I work in a world where we are managing terabytes and terabytes of data. And anytime you query that much data, performance is a big concern. We don't have users who are willing to wait around for hours to get a return. In fact, they'll start complaining if it goes more than a few milliseconds. So on to the demo. Let me show you, remember this is an anti-patterns presentation, let me show you a bunch of ways not to do it And I will even throw in a few hints of ways that other professional coders have helped me improve upon those queries. But from the SQL Server standpoint, let's switch over to a quick Visual Studio application that I've written. And this is just going to do some real quick sample queries. So let's say that we have a business case. We just want to be able to look up people by last name. And I have a query that will do that. I have named it First Query. This query looks something like this. It's a simple console application, and I am just going to ask the user to enter a last name. I will read that in from the console, and then I will do this quick Entity Framework link statement that pulls in my people object from my Entity Framework context and selects all the people. I will then go through each of those and find the ones that match the last name. If we bring up my Solution Explorer, I will show you my context. This is an Entity Framework context. I'm using EF6, and it is built against the AdventureWorks sample database that comes free from Microsoft. And behind the scenes, I have a database server that is running that. And that is right here. So before we run this program, let's use a tool called SQL Server Profiler. And what it'll do is it will intercept the T-SQL that is coming from any client and show us what that T-SQL looks like. I'm going to go ahead and get rid of some of the noise that comes with the default trace. And then we will run that. So this will capture anything that comes into that SQL Server. Now, I really like live demos. However, they are fraught with danger and can cause me a feeling of terror. So here's hoping that all of this works as designed. We run this console application. And before I started doing any of these courses, I actually looked up in the AdventureWorks for one of the more popular last names, and it was actually Gonzalez. So let's search for the last name of Gonzalez. And I apologize about the size of these console screens. But entering that last name, it's going out to SQL Server, it's going through the optimization process, it's getting me a query, and it's returning the business IDs of everyone who has that last name, which is like the code that I've written. Pretty simple business case. All I wanted was the ID back. That's what I have written out to the console line for anything in the database that has the last name of Gonzalez. Let's see what T-SQL was passed by Entity Framework. So what we have here, and I'm going to copy this into bear with me, I'm going to copy this into SQL Server Management Studio so we can zoom in and take a closer look at it. This is the query that was passed. If you know anything about T-SQL, right away you're noticing there is no where clause. And I have selected every single column in the entire data set. Now, for those of you who are good Entity Framework programmers, probably long ago you were saying that is a terrible way to use Entity Framework. And that looks like this. Well, good. I'm glad that you identified that because you're right. Unfortunately, as a database administrator, I see this kind of stuff all the time. The conversation goes something like this. A developer will come over, and if any of you know what DBA actually stands for, it stands for don't bother asking, because DBAs have a reputation for kind of being jerks. And you know what? I'm working on that. And frankly, in the SQL Server community, it's kind of something that's known and laughed about, but there are a lot of amazing, outstanding people. Go to a SQL Saturday sometime and show interest in SQL Server, and you will be amazed at how nice the community really is. But conversation will go something like this. Hey, I'm a developer. We got this code. We just pushed it to production. In test, it looked fine. It worked great. But the program's been running for about a year now, and it's really slow, and we're getting a lot of complaints. Can you help us see why it's slow? DBA says, sure. He runs a trace and ends up seeing something like what we just passed. And he says, well, I know that your performance problem, I got it right here. You're pulling back the entire table. And a year ago, that table had 200 rows in it. Now that table has several thousand rows in it, or 100,000 rows in it. So don't pull that kind of query. Pass in a where clause. And in fact, do you need all these columns? No, we actually only need the business entity ID. Okay, as a DBA I say, well then get rid of all these columns. And then the answer sometimes is, well, I didn't write the query. It's Entity Framework generated it for me. And the DBA, who's in a hurry and has 100 other pressing things, says, well, then Entity Framework is a terrible product. Well, there's a lot of area in between those two. But this, frankly, is why Entity Framework, as of yet, still doesn't have a great reputation among database administrators, because on their end, they see queries like this to satisfy a business need where really I only needed a entity ID and a where clause. So if I were going to write that myself, it would look something like this. Where last name equals Gonzalez. And, whoops, I'm in the wrong context here. Okay, that's my result. If I go over here and see the estimated execution plan, it's a really simple query. It only had to do one estimate, and it says that's easy. I'll just do an index seek because I'm searching by last name Gonzalez. Well, compare that to what we had before. Let's see that execution plan. It's similar. It seems just as simple, but there is a big difference in the estimated costs. And if we go back and rerun this, because I've been doing some things, I've dirtied up my profiler trace. Let me just stop this. We'll start a fresh one. Where the real impact comes is when I run this, pass in the exact same thing. Wait for it to run on this end. This column right here is the one that I am most concerned about as a DBA. That query caused 3,820 reads. Each of those reads represents a data page. So if I bring up my calculator, I cannot do math in my head. I got 3,820 times 8. That is 30,560 kilobytes. So that's already 1,000. So we have 560 million bytes and 30 billion bytes. If I'm doing my conversions right, that's roughly 30 gig of data to satisfy this query. If, however, I did it my way as a DBA, like that. Entity Framework likes to put aliases on these things, and that's just fine, but I have to be aware of that. Okay, there's my query getting back the exact same data And if we look at that, here's the second one. My reads are all the way down to 8. So that's a difference between 3,820 versus 8. And so that's why a DBA would say, this query is your problem. So in my code, how can I make this better? Well, first of all, don't ever do this. Don't filter the result set of your query in code. Filter your result set as part of your link statement, or if you do Lambda, or however you communicate with your entity framework context, you want to be doing your filtering up here. So we'll change that. Whoops. Now the link syntax is a little bit backwards, so if I mess up here, bear with me. But where from people in DB people where people last name equals the string last name. So now I can get rid of this line. If I rerun that, same exact thing, same exact results, should be. It's taken just a second. And if I bring up my trace, I've reduced my reads by about 10%, which is, that's outstanding. I'm still not down to 8. I'm at 385 because you can see the difference here. I am just selecting the business entity ID, but that entity framework query is still selecting every single column in that entire table. So I have one more fix that I need to make to this query. I need to use a concept known as you know what, the concept literally has completely left my head. You need to watch my course. This is where it shows that I am not a professional coder. I am a DBA. What I want to do here is I don't want to select the entire people object. I want to select a new object that is made up of a smaller object that is just a subset of that. So if my business case is I only want back the business entity ID, I don't need to select the entire object. I can just select new people business entity ID. And this will allow my query, it now knows this is the only thing I'm interested in, so when it converts this to T-SQL, we run this again. Got to spell it right. What we get now is, look at that, 8 reads, just like the query that I would have written myself. So the moral of the story is, and I finally remembered what this is called, use the concept of projection. It projects a larger object as a smaller object. By creating a new object that is a projection of this object, I have now told Entity Framework that I'm more explicit in what I want. And so that saves a massive, massive amount. Because keep in mind, all of those data pages potentially have to be read off of disk and put into memory. But more importantly, what's killing SQL Server performance is if memory doesn't have room for those 3,820 pages, it's going to have to evict other data in order to make room, because SQL Server only works in memory. Everything it does is in memory. So if it has to evict other pages to make room for your query, that's affecting other people's data performance. The longer that pages can stay in memory, something known as page life, the higher performance you're going to get out of your SQL Server because it doesn't have to go all the way to disk. Disk is slow, memory is fast. All right, so, boy, I'm really glad I remembered what projection is called. That would have been embarrassing. Okay, so we have looked up a person by a last name. That's not very useful. I would rather look up someone by email. So I have a little second block of code here that will look up someone by email. The problem with that is that here in my data context, if we go look at, if we go look at the person table, right here, you see that email isn't part of this table. Email is a related table. Awesome. I'm a DBA. I love relations. That's what makes SQL Server fast and also gives you the ability to have context. This is a one-to-many relationship. So if I want something out of here, but based on something out of here, in Entity Framework, it makes this really easy to just code right out of the gates. I can do something that looks like this. I will enter my last name to search an email. I will have that same kind of object from people in my people context where last name equals string last name. I'm being a good developer. I'm putting my filter into my statement there. But I'm selecting people. Well, I want to query by email address. So how is it, how am I going to get back the emails when this here is done by people? And also it makes it hard to use projection because, again, I have no concept of email here. The Entity Framework is really cool in that I can loop through each of the entries in this object and then, whoops, sorry about that. I still have that query from the other window. Again, the dangers of doing live demos. When I loop through each of those objects, I can gain access to those email addresses right here in that object. Because Entity Framework is pretty smart. It knows through my context that these two tables have a relationship. And so by creating an object here, I automatically have hooks into this email address table. So let's see how that looks in our trace. So I'm going to call my second query. I have, let me stop and restart my trace so that we get a fresh set of data. All right, and we'll run this. So again, I want to see all the email addresses related to the last name of Gonzalez. Pretty simple query. And here comes back all the email addresses. Awesome. Let's see what we have in our trace. Woo! That is a lot of entries. What has happened? Let's start here at the beginning. I have a SQL statement that pulls back the entire content of the person table, which I don't care about any of these rows or any of these columns. I do care about the rows because I'm looking for where the last name equals Gonzalez. But I don't care about any of this other stuff. What I wanted was the email addresses. Now, Entity Framework made it real easy for me to conceptually go acquire those email addresses, but the way it did it is by running this query over and over again. If we go through each of these queries, you see one explicit query after another passing that foreign key that links email address to the person over and over and over again. As a DBA, if I started receiving complaints about a slow SQL server and I opened it up and saw 240 rows to satisfy the query, I want the last names or the email addresses related to people with the last name of Gonzalez, I would immediately say this is a ridiculous way to get this kind of data. Again, if I were going to do it, it would look something more like this. I would just say from person.person, inner join person.email address. I already have my where last name equals Gonzalez, and I don't care about business entity ID. I just care about the person, email address, email address. That's all I want. Whoops, I forgot my on clause. On person.business entity ID equals person.email.business. I've spelled something wrong. I hope you guys are all really enjoying me watching a professional DBA make an idiot of himself trying to type T-SQL. Let's just do this much easier. I'm going to say P and E and E, E, then I just want email address. Thank heavens for IntelliSense. Okay, sorry, that took a lot longer than I intended. Here are those email addresses. Now we have a lot of stuff to look at, but ultimately, all those queries that I ran have individually not a lot of reads, 2 reads per query. So, okay, 16 kilobytes, whatever, that's not a big deal. I mean, maybe if we were in the 80s. But my problem is the scale. If this was a table with hundreds of thousands of rows, well, that really adds up. Plus, SQL Server is not good at doing iterative things. It wants to do single set-based things. Plus, don't forget, I still have to add it to that 382 reads there. So if I kill this, start a whole fresh new process, and run my improved query, we'll run it again so that it's picked up by the profiler, I am down to 255 reads for the whole thing. So how do we get Entity Framework to satisfy that same request, but with a query that looks more like this? Well, there's a couple of different techniques. One, we can use, I'm only just now realizing that here in my demo, I kind of named them weird, but we can use a concept known as an include. So I can say, just like I did above, from people in DB people, and oh, by the way, include email address in that, where people last name equals the last name I pass you, select all the people. Everything else about what I'm doing here is identical. I'm looping internally through each of these in very much the same way. I am printing out the email address. The only thing I have done is I have warned my link statement ahead of time that I'm going to be leveraging that related email address table. So let's see how this runs. Let's see what that looks like, if it's any better. Uncomment query 3. And the last name that I'm searching for is Gonzalez. If I've done everything right, I'll get back my email addresses. And then if we go look at the trace, we have a query. All right, boy, what a query. So the good news is we have met the exact same thing in a single set-based approach. We've only had to go through the query optimization process once. And there is overhead there. Also, we haven't had to repeatedly reach out to disk and delegate all that work out to the disk subsystem to get those pages into memory. However, I'm still at about twice as many reads for a pretty simple query. And frankly, I'm surprised that it's only that much bigger, because look at all this. All I wanted was email addresses, and I got back a massive amount of data. Why can't I just get something that looks like that? Because that is way easier for the query optimizer to compile and to give me a really good, concise plan for acquiring that data. Well, the problem with the include statement, and believe me, it is better than the previous attempt, but the anti-pattern here is, first of all, anytime you are having to loop through an object you've developed, and then especially if you have to loop through it again, if you have nested loops on anything that you've done up here, that's immediately a hint that you could have done something better here to keep from having to do all this. Because usually this block of code, these for each loops and any kind of looping structure, is going to force Entity Framework to have to reach out to SQL Server and ask for more data or append its previous requests. The include statement that we used to make our query better, it warns that initial link statement that, hey, I am going to come back for more data out of that email address. So bring everything related with that email address along with the people, everything related to the email address table. Bring that back with the people. That way I don't have to go all the way back to SQL Server. I will just have it here in my local object, and I can get it right out of there. However, it still is telling SQL Server to bring back every column related to both people and the email address. So why can't I use projection here like I did above? Well, the problem is I only am working with a people object. So if I say new, and I try to use projection to get down to that email address level, there's no real concept, because this is the email address table. That is that related table. That is not the column level email address. And so, okay, well, let me try people then. All right, well, here I have the email addresses table again, but again, I'm not able to drill all the way down to get just this column, email address 1. So include definitely improves upon this query. And these are very, very simple and very specific use cases. Believe me, there are places where I would say, knock yourself out, use an include. But what if instead we just told Entity Framework right here up front in a sample below that I am going to do a join. I want a query just like I am getting. There's a couple of ways to do this. One, I can use lambda expressions. Now, lambda expressions scare me. Anytime I see this little equal arrow sign, I know that there's something here that is going to be way over my head, because I am not a professional coder. For those of you who are comfortable with the expression syntax and the way that these lambda expressions work, I would highly encourage you to use them, because working with my own developers, I have found that they produce really good T-SQL, because this, for whatever reason, this allows Entity Framework to get at the heart of what you are doing. If you are more like me and find the lambda expressions just terribly confusing, I'm going to comment that out. You can also just use an explicit join. Now, the immediate complaint is that is a lot of syntax, and it looks very much like a T-SQL statement. And one of my #1 reasons for using Entity Framework is so that I don't have to think about joins and T-SQL statements and how everything works, because that is not where I, as a developer, am comfortable. My answer to you is, okay, that's fine. I totally get that. However, if it's performance you're after, this is a better way. And so ultimately, you're going to have to code the way that's going to pass the best T-SQL to that query optimization process in order to get your performance desires. If performance isn't a concern for you, I frankly don't care how you knock this out. But I kind of warn you, databases that don't have a performance problem today often grow up. We all hope that our businesses grow, that we add more customers, that we have more and more business transactions. And so even though it's not a performance problem today, it really could become a performance problem. So let's, I'm going to use this lambda expression just because it makes me feel smart, even though, like I said, I hardly understand it. And the other thing I like about the lambda expression is it's just less code. And so I think DBAs and coders alike could agree that anytime it's less code, it's got to be better, right? So let me go make sure that do fourth query is uncommented up here. Let's see what that looks like. Oh, so of course, I have broken something. Oh. I will fix you later because we've already passed you. That was code from our last. Tell you what, I'm just going to comment out this whole thing. Again, the dangers of doing live demos. Even with the problems of live demos, I still prefer it because, frankly, I think it just sinks in way better when you get to see this stuff in action. So hopefully you're not annoyed by the fact that I'm doing all this live. All right, do fourth query. All right, our favorite last name, Gonzalez. I'm going to get back the exact same email addresses that we always have. Now let's look at our query. Ta-da! 255 reads, just like the query that I would have written as a DBA. Now it's a little more wordy, and that's fine. Like I said, Entity Framework likes to put aliases in front of everything, and it's very explicit. I don't have a problem with that at all, because what I'm concerned about as a DBA is this. I want the fewest reads possible. And I also am really concerned about how this query gets optimized. So, fantastic. With that, I have a query that is fast and performant and runs just like a query that I would have written myself. But sometimes we have so many query results, and that was our intent. Maybe we're going to, if we search and Gonzalez has hundreds of thousands of entries, we don't want all that data. We might still be tempted to go in and pull back the entire object, but then page it out, only show 10 or 20 at a time. After all, that's how a service like Amazon works. Imagine going to Amazon and searching for cheap sunglasses. You're going to get back hundreds of thousands of pairs of cheap sunglasses. But Amazon doesn't drown you in all that data right up front. They show you 10, 20, 50 at a time based on your preference. Well, it's very common for us to want to do that as well. Entity Framework has built-in methods and concepts of lazy loading, because that is what that is known as. Even though I have hundreds of thousands at my disposal, I'm only going to load 10 or 20 at a time. I have had the conversation with many a developer that an approach like what we did on this query that went back to the database several hundred times to look up all those email addresses is better because it's lazy loading, and lazy loading is better. Lazy loading can be better. It all depends on your context. when you are not wanting to inundate your end user with all the data at your disposal, I am totally a fan of lazy loading. Only get what you need. But what you need and how you get it are still two different things. So on this fifth query, in the interest of time, because there's still some things I wanted to show you, and when I was going through my own practice sessions, I was going to set up a demo that would show you a traditional lazy load approach. In this one, we're going to skip right to the chase, and I'm going to show you a good way to lazy load, but where you're working with SQL Server. Entity Framework has, and remember, I'm on 6 here, Entity Framework 6. And I understand 7 is even better. Julie Lerman, who's another Pluralsight author, knows Entity Framework far, far better than I. She has some great presentations on EF7, most of which are completely over my head. But as a DBA, I'm really excited because SQL Server finally has a concept of skip and take, like other products like MySQL have had for a really long time. And Entity Framework can now take advantage of that by using that type of thing. So in that exact same query that we ran above, this is one of the few areas where I'm okay with putting your Entity Framework link syntax inside of a loop. Usually when I see that, I'm thinking, why is it in a loop? Why can't you just do that as one single set-based approach? Because that's the way that SQL Server likes to work. Well, in this case, it's still a set-based approach because I am only passing the fact that I want 10 records right up front. I'm telling Entity Framework, I only want 10 records. I'm not saying give me everything you have, even though I'm only going to look at the first 10. And there's a big difference. The loop I have here loops through, and I just use I as a looping integer, and so I times I by 10 for my skip. So the first time this runs, it'll be 1 times 10, so it'll skip 10. The second time it runs, it will be 2 times 10, so it'll skip 20. So what's going to end up happening is I'm going to get the first 10, and then if I run it again, the second 10, and if I run it again, the third 10. So what does that look like? Make sure that my sample code is the one that's going to run. Yep, do fifth query. I go a lot deeper into a lot of this in my own Pluralsight course, which is Database Performance Anti-Patterns with Entity Framework. You can find it on Pluralsight, and really I go much deeper. We break down even the query optimization processes deeper. We dig into all these concepts. But frankly, you're getting a good exposure to it even in just this hour module. Searching that last name, there you go. I get my first 10, and after I hit enter, I get my second 10, and after I hit enter, I get my third 10. And what that looks like in my profiler is this. I have a pretty simple query, and it's using row number to partition that stuff out and give me row numbers greater than 30, row numbers greater than 20, and row numbers greater than 10. And individually, my reads are still 255 pages. But if you add each of these requests up, it is far, far less than the original 382 times, what was it, 224 rows times 2. So, you know, roughly 5 or 6 times the amount of data for the same query. And that is with this use case. Imagine if this were hundreds of thousands of rows. Also, by letting SQL Server do it set-based, it lets the query optimizer figure out the best way to go get that data on disk, as opposed to just kind of an ad hoc end-to-end approach where it would be, frankly, just as easy to read it out of a text file without the query optimization. So that is some entity framework do's and don'ts. Let's recap real fast. Absolutely do, use projection. This will reduce the number of columns. In that people table, imagine if we would have had a column that stores a picture of the person. And with today's 10, 20, 30 megapixel cameras, that could be gigabytes. And so let's say we have 1,000 people that all have a picture, and we are querying every column in that object and bringing that up into SQL Server memory across our network into our local memory space and parsing through it, because we just were too lazy to add an extra new line and be specific about the column that we wanted. Frankly, these AdventureWorks databases aren't that huge, and in practice, these things can get pretty massive. So do use projection. Don't use simply select people, because even though it's easier to write, you aren't being specific. The second do and don't is don't nest your requests for additional data inside of looping structures. Try to figure out a way to get all of your requests done in your link statement or whatever way that you're communicating with your SQL Server database. Get it all up front, because this will reduce and potentially drastically the round trips. That could look like either using the include statement to be specific about saying, hey, I am going to come back and want more data out of that table, or by getting rid of that whole for each loop construct with something like this, where you're doing an explicit join. Either an explicit join with traditional link syntax, or using the select many and the select methods inside of a link statement with lambda expressions. Both are good, both work. This one is less code and tends to compile better in my experience. And lastly, I'm okay with lazy loading, but don't use lazy loading as an excuse for you as the developer to be lazy unless performance is not an issue. If performance is not an issue, then great. I mean, one of the best things about Entity Framework is how quickly I can generate code. But where performance is a consideration, by abstracting away the T-SQL, that responsibility is now on you and your coding in .NET and Entity Framework. It's not going to be the responsibility of the query optimizer to figure out your intent when you haven't told it what that intent is. So there's some quick do's and don'ts. The last thing that I really wanted to cover today is code ahead. Let me bring up my, I have a project here. I thought I had already had it opened, but that's okay. It's called SQL Logging, because I'm going to show you two things really fast. First thing I'm going to show you is code ahead is a really interesting concept where you can declare your database objects as classes and have them built for you on the fly. It looks like this. For those of you who haven't seen code ahead or haven't used code ahead, I'm not going to be able to give you any kind of introduction here. For those of you that have, this is a common construct. If you use code ahead, let me give you just one quick do and don't. I've written a quick application here that just asks for a department name, and it will enter that into that department table. If that database doesn't exist, so I'm going to say accounting, code ahead creates it for me. That's pretty cool, frankly. On my trace, you can see all of that happening. Oh, actually you won't, because it's a different database instance. That's fine. I will close that. And let's see what got created. Look at that. It created a whole new database that wasn't there before, and it created new tables and the whole bit. As a DBA, I immediately check out when I see this. a department name as varchar max, specifically nvarchar max, because unless we're using languages outside of the Latin collation, I'm storing twice as much data for no reason. And by saying varchar max, I'm saying I could put literally, phone books worth of information in there. The common argument by a developer is, well, it's a variable, it's a var, so it could be as long as it wants. What's the difference between a varchar max and a varchar 50? And the answer is the query optimization process. You have given it nothing to work with when you pass it a varchar max. Query optimization sees varchar max and thinks, man, I may have to work with potentially billions of characters, and it might just be a last name. And so you're circumventing your query optimization process by not being specific about what you want. So I'm okay with you using code ahead. What I would ask is that you go the extra mile and either use the Fluent API or other approaches to be more specific about your data, because data types matter. Watch my course, we go into that a lot more. But do things like specify that it is going to be a 50-character length, that you're not interested in it being Unicode if it doesn't have to be, because those cause huge disk savings, and that's fewer data pages that have to be read into memory, less possibility for data pages to be evicted out. With that, that is going to be my last tip because we're out of time. But if you have other questions or would like to reach out to me, one thing that I do show in the course that I wasn't able to show here is how to get that T-SQL to work with your DBA. If you pass your DBA a link statement, most DBAs aren't like me and also code on the side or have time to understand link. You don't have to use SQL Profiler to intercept that T-SQL code. You can, the reason that my project was named SQL Logging is because in this code, and I'm not sure if these webinars have the ability for you to download code. If they do, I'll happily upload this. But I have logged everything that I just did to a text file, and it's out here on my C drive. And so I don't have to run up an instance of Profiler, which most DBAs aren't going to be real happy about, especially in a production environment. But I now have the ability in Entity Framework to capture all the T-SQL statements that get generated and passed right here in this logging file. So it's fantastic for debugging. If you want more information on how to do that, it's out on the webs. I go more into depth in my course. Frankly, reach out to me on Twitter, and I'll point you in the right direction as well. So with that, I'm going to turn the time back over to our moderator.
All right, thanks, Russ. I really appreciate it. I'm going to go ahead and stop sharing the screen here, and we will actually link to your course when we send out the link to the recording. If there's any other information, we'll share your Twitter handle as well and any other details that you want to share. It looks like we are out of time. If you have any other closing remarks, Russ, that you want to share?
My only closing remark is I feel bad that I wasn't able to answer questions in the time that we had. So reach out to me on Twitter. I will answer them if I have the answer, if I'm smart enough. If not, I will point you at someone who is.
Awesome. Thank you so much. Thank you for presenting, and thanks everyone for your participation. We really appreciate it. If you have any questions, again, find us on Twitter. We'll point you in the direction of Russ on Twitter if you can't find him. If you would like to contact us, you can email us at webinars@pluralsight.com. And please complete the survey before you leave. Thank you once again. Have a wonderful day.